The ACT is coming up, and I feel like there's two main questions you probably have. How am I supposed to study, and where am I supposed to find practice problems? Well, that's what this video is for. I've put together over 40 example problems, all gone through step by step to help you practice for the ACT math section. So good luck studying, and why don't we get started with the very first example problem. So here's the first problem that we'll be doing in this video. It says if b is equal to -3, what is the value of 4b squared minus 2? Now, when it says to find the value of something, we're just looking for a number. And the only thing that's stopping us from finding what number this is equal to is the letter b, because we can't really do math with letters, right? But we know that b is equal to -3. So how about we just plug in -3 for b and then solve it? So I'm going to rewrite 4b squared minus 2, but instead of b, I'm going to write -3. And I'm putting it in parentheses so that we don't get confused over it being like subtraction or anything. Now we just need to simplify this. And to find out which step to do first, we're going to need to use PEMDAS, the order of operations. So the P in PEMDAS stands for parentheses, but the only thing in parentheses is this -3 just by itself. So we can't really do anything with that. So let's move on to E, which is exponents. And I see here we have -3 to the power of 2. So that's -3 multiplied by itself. -3 times -3 is, well, 3 times 3 is 9, and then two negatives make a positive. So -3 squared is +9. So instead of -3 squared, I'm going to replace it with 9. And now the next step is multiplication and division. And here we have multiplication. Whenever you don't see a sign in between things, that means multiplication. So 4 times 9 is 36. And then all that's left is, well, the addition and subtraction, but we only have one thing left here. 36 minus 2 is 34. So there we go. We've found the value of 4b squared minus 2. It's 34. All right, here's the first word problem of this video. There's going to be a lot of those on the ACT. So it says for a certain cleaning product, the ratio of solution to water is 1 to 12. How many cups of solution should be added to 3 gallons of water? So basically, we need to have a certain amount of solution, which, just like cleaning solution, and then a certain amount of water. Now, it says there are 3 gallons of water, but we have to figure out the amount of solution in cups. So that's an important thing to know for these problems. You need to know what your units are. And then it says that the ratio of solution to water is 1 to 12. So basically, for every 1 cup of solution you have, you're going to have 12 cups of water. So for example, if you had 24 cups of water, then if you wanted to find out how much solution there is, well, we could just divide by 12. And 24 divided by 12 is 2. So then 24 cups of water means 2 cups of solution. So we could just do that with this, but there's one problem, and that is that this is in gallons. So for this to make any sense, we need to switch the 3 gallons into cups. So it gives us a little hint here. It says that 16 cups is equal to a gallon. So how do we find out how many cups are in 3 gallons? Well, we can just multiply it by 16. So if you put this in your calculator, 3 times 16 is 48. So 3 gallons is equal to 48 cups. So now we can use our ratio, which is 1 to 12. 1 cup of solution, 12 cups of water. So we'll just do what we were talking about before. We'll take our 48 cups and we'll divide it by 12. So 48 divided by 12 is 4. So our final answer is that there are 4 cups of solution for 3 gallons of water. Okay, here's our third problem. It says Bob sells 3 flavors of ice cream. Yesterday, half of the scoops sold were vanilla, a fourth of them were chocolate, and 7 were strawberry. How many total scoops did Bob sell? So where do we start with this? Well, the way that I think we should start is we should figure out what fraction 7 is. What fraction is strawberry? And remember that the fractions should all add up to 1, to 100%. So 1/2 of the scoops sold were vanilla, and 1/4 were chocolate. So what's left over for strawberry? Well, let's start with 1, right? 1 is the total of all the fractions. And then 1/2 is being taken up by vanilla, and then 1/4 is being taken up by chocolate. So what's left for strawberry? Well, let's go ahead and convert these fractions into numbers that we can work with. So remember that if a number's not a fraction, it's just over 1. And we can get these as a common denominator. I'm going to try to get them all as a denominator of 4. So to get the bottom numbers all to be 4, let's multiply this fraction by 4 over 4. Because remember, as long as you multiply it by the same number top and bottom, then it's fine. So 4 times 1 is 4, and 4 times 1 is 4. So 4 over 4. And now 1/2, this is already a 2. So to make this a 4, we just need to multiply it by 2. So 1 times 2 is 2, and 2 times 2 is 4. So 1/2 becomes 2 over 4. And 1/4 already has 4 on the bottom, so I'm going to keep it the same. And now because these are all in fourths, we can do our subtraction. So we have 4 fourths, we're subtracting 2 fourths, so that's just 2 fourths left. And then minus another fourth, so we only have 1/4 left. 4 minus 2 minus 1. So this means that 1/4 of the ice cream that was sold was strawberry. And we also know that 7 scoops sold were strawberry. So I think this will make more sense if we think about it visually. So here are all the scoops sold, right? This is the total sales for the day. And because this is in fourths, let's go ahead and divide it into fourths. Now here are the strawberry sales, right? And 7 scoops were sold, and they make up a quarter of the total sales. Now remember that we don't need to figure out how much vanilla and how much chocolate was sold. We just need to figure out the total amount. So let's just think about this, right? If a quarter is 7, then that means this quarter is 7, this is 7, and this is 7. So to find the total sales, let's just add these up. 7 plus 7 is 14, plus 7 is 21, plus 7 is 28. So if you add these together, there were 28 total scoops sold. So sometimes you don't even actually have to write out a math equation. You just have to think about it logically, think about it visually, maybe even draw something like this if it makes sense to you. And there we go. We've come up with our final answer, 28 scoops. So here's a probability problem. It says that Mr. Person flips a coin and rolls a 6-sided die. So he's doing 2 different things. He's flipping a coin and rolling a die. So what is the probability that he flips heads and rolls a number less than 5? So he's doing 2 actions, right? We need 2 things to happen. We need him to flip a coin, and this coin needs to land heads. And he's also rolling a die. And this die needs to land on a number that is less than 5. So let's figure out what the probability is of each of these things happening by themselves. And then we can combine them to figure out the probability of both of them happening at the same time. So first of all, what is the probability of a coin landing on heads? Well, probability is always the number of ways you could do it successfully over the total amount of possibilities. So a coin only has 2 choices, right? It's either heads or tails. And how many of those 2 choices would be a success? Well, only one of them, because if he flips heads, then it's a success, or if he flips tails, then it's not a success. So the probability of flipping heads is 1 over 2. Now, what about the die? This might be a little more complicated. It needs to roll less than 5. So how many different possibilities are there for a die? Well, you can roll a 1, 2, 3, 4, 5, or 6. So there are 6 different possibilities. But it's not going to be 1 over 6. Out of those 6 possibilities, how many of them would be a success? Well, it's any number that's less than 5. So that would be 1, or 2, or 3, or 4. It wouldn't be 5 or 6 because neither of those are less than 5. So there are 4 possibilities for success out of the 6 different numbers that we can roll. So our probability is going to be 4 over 6. Now we could go ahead and simplify this fraction, but I'm actually going to do the combination first and then just simplify the fraction. So we have our 2 probabilities now. So how do we combine them? Combine the chances of both of them happening? Well, you might think that, oh, well, to combine them, we'll just need to add them together, right? 1 over 2 plus 4 over 6. But that actually doesn't make sense because when you add them together, you're increasing the chances. And the chances of 2 things happening at once seems like it would make it harder. So to find the chances of 2 things happening, we actually have to multiply the probabilities. So we're going to take 1/2 times 4 over 6. And remember that to multiply fractions, you multiply the tops and you multiply the bottoms. So 1 times 4 is 4, and 2 times 6 is 12. So the probability is 4 over 12. Now, before you just go ahead and accept this answer, we need to ask ourselves if we can simplify the fraction. And if you were doing a multiple choice problem, for example, this probably wouldn't be an option to pick. So how do we simplify this? Well, it looks like both of these can actually be divided by 4. So if we divide both the tops and bottoms by 4, 4 divided by 4 is 1, and 12 divided by 4 is 3. which means that our simplified fraction and our final answer is 1 over 3. So basically, if you were to flip a coin and roll a die, then the chances of both of these happening at the same time is 1 over 3. And that makes sense. It's a little bit less than the 1 over 2 for flipping the coin. Now here's a geometry related problem. It says, what is the diameter of a circle with an area of 50.24? Now here's the little bummer about the ACT math section. If you've ever taken the SAT, you may know that it gives you a formula sheet that you can use for geometry problems. But most of the time, the ACT is not going to give you any formulas. You'll have to know them already. The good news is that a lot of these formulas are actually pretty short. Like, for example, the area of a rectangle is length times width. But here's an important formula to know, and that is the area of a circle. And I know that even though we're solving for diameter, I'm probably going to use the area of a circle formula because it gives us the area. The area of a circle is pi times the radius squared. Now you may be asking yourself, well, we're trying to find the diameter, right? So why are we doing a formula with radius? But remember that for a circle, just pretend that this is a perfect circle, the radius is basically the distance from the middle to like the side of the circle. So that's the radius. But the diameter is all the way across. So the diameter is basically just 2 radiuses. So if we found out what the radius is, we could just multiply it by 2 or add it to itself and figure out the diameter. So let's go ahead and plug in what we know for each letter. This is how you use formulas. You just plug in every number that you know. So A, we're going to replace with 50.24 because we know that that's the area. Now pi is always 3.14. So depending on the problem, you might have to replace pi with 3.14, or you leave pi the same and just treat it as if it's like a variable. So if you're not sure which one you're supposed to do, then look at the different answer choices for the problem. And if they all have pi in it, then I would just leave pi the same. But if they're all just numbers, then you can replace pi with 3.14, which is what I'll do for this problem. And now r, I'm going to leave as r because that's what we're trying to figure out. That's what we're solving for. And r is going to be squared. So let's just go ahead and solve this algebra problem. We need to get r by itself on one side of the equation. And basically, we're doing like reverse PEMDAS. So we have an exponent here. That's pretty early in PEMDAS. So I'm going to do that last. I'm actually going to get rid of this 3.14 first. And remember that this is multiplication when there's a number and a letter next to each other. So I'm going to do the opposite of multiplication, which is division, and divide both sides by 3.14. So these cancel out. On the right side, we just have r squared. And on the left side, we have 50.24 divided by 3.14. So if we just go ahead and put this in our calculator, we should get 16. So r squared is equal to 16. The last step now to solve for r is to get rid of this squared. And the opposite of squaring is square rooting. So I'm going to square root both sides of the equation. So the square root and the squared cancel. On the right side, we just have r. And on the left side, we have the square root of 16. That's what number do you have to multiply twice to get 16? Well, 4 times 4 is 16. So the square root of 16 is 4. Now, technically, when you're square rooting both sides of an equation, you're actually plus or minus square rooting. So this would be plus or minus 4. But the lengths of lines are not going to be negative. So we're just going to use the positive answer of 4. So our radius of the circle is equal to 4. But always remember what the question was asking. It was asking for the diameter of the circle. So how do we find the diameter? Well, let's go back to our circle diagram from before, our perfect circle. And our circle is going to have a radius of 4 something, centimeters, inches, or whatever, I don't know. But we're looking for the diameter, which is all the way across. Well, that's just going to be another radius, and that radius is also going to be 4. So let's just add these together. 4 plus 4 is equal to 8. Which means that the length of our diameter is 8, and that is our final answer. On the ACT, there are 5 different kinds of math problems that you can expect to see, and the mistake that a lot of students make is that they don't study for all 5 of them. So here's an example of every type of math problem you can expect to see on the ACT. So the first type of problem on the ACT is just called a number and quantity, which is just about numbers, and apparently that includes imaginary numbers as well. This is one of those things that you might not remember how to do, but once you do remember, it'll be really easy to solve in the future. So for this problem, it tells us that I is the square root of -1. That's just a standard math thing for imaginary numbers. And it wants us to find the square root of 4 plus the square root of -9. Well, the square root of 4 is not that bad because that's just a regular square root. It's what number you have to multiply twice to get 4. And in this case, that's 2, because 2 times 2 is 4. And that's just going to be plus whatever the square root of -9 is. So I have a feeling it's going to be either C or D. I can't imagine it being A or B. So what is the square root of -9? Well, we have the square root of -1. So let's split this up into two square roots, one of them being the square root of -1. So we can split this up into the square root of 9, positive 9, times the square root of -1. This is how you do any negative square root. So the square root of 9 is 3, because 3 times 3 is 9. And the square root of -1, the problem says, is the letter I. And in algebra, you don't have to put multiplication signs, you can just put them next to each other. So the square root of 4 plus the square root of -9 is 2 plus 3i, and that is going to be answer choice C. So that's the answer to this problem. So this is the second problem. If you want, you can try to work this out on your own, maybe pause the video and try it. We have a system of equations, and we need to find the value of y. So normally you have to find x and y, but it's saving us time. We just need to find y. Now there's two main methods to do this. There's substitution and elimination. I'm noticing that the bottom numbers are always doubled from the top numbers. So I think it'll actually be easier to do elimination. The goal of elimination is to add up these two equations so that it eliminates a variable. And because we're trying to solve for y, I think we should try to eliminate x. Because if we eliminate x, then there will just be y left over and we can solve for it. So I would suggest that you always ask yourself, it would be really convenient if these numbers were what? Usually you want to start with a small number. If this number was what number, it would be really convenient. And personally, I think if this number was a 4, it would be really convenient because we would have a 4x and a minus 4x, and then those would eliminate, and there would only be the letter y. So how do we get from a 2x to a 4x using multiplication? Well, we have to multiply by 2 because 2 times 2 is 4. But we can't just multiply this number by 2. We have to do it on both sides of the equation. So I'm going to multiply this entire equation by 2, and we'll see what happens. So 2 times 2x is 4x. 2 times y is 2y, and 2 times 1 is 2. So we've multiplied this equation by 2, and now this other equation, we haven't done anything with it. So it's just going to stay exactly the same. And now we can add these two equations together. So 4x minus 4x, that cancels out to 0. That was our goal, right? But then here we have 2y minus 2y. Well, those actually cancel out as well. We didn't mean to do that, but it just happened. So I guess we cross these out too. So this entire left side of the equation is just going to be 0. And then we add up 2 plus 7. 2 plus 7 is 9. So after doing elimination, we have ended up with 0 equals 9. Well, that doesn't make sense. 0 does not equal 9. Did we do something wrong? Well, no. We tried to eliminate one letter. We ended up eliminating both. So no matter what you plug in for x or y, you're always going to get something that's not true because 0 does not equal 9. So in this case, the answer is actually D, no solution. There is no way to get both of these equations to be true. Okay, this is the third category of problems on the ACT, and it's just called functions. So how do functions work? How do you do things with functions? How do you graph them? And so on. So here's an example where we actually have two different functions. We have f of x and g of x. Remember that f and g are not different in any way other than that you use them to show there are two different functions. So the first one is f of x equals 3x minus 2. The second one is g of x, which is the square root of x minus 1. But you'll notice it wants us to find f of g of 5. So the fancy term for this is a composite function, but you don't need to know that. Basically, you just need to notice that ultimately we're solving for f, right? But the number that we're supposed to replace x with for f of x is g of 5. So we actually need to work from the inside out. We need to figure out what g of 5 is, and then that will give us the number to solve the f function. So what is g of 5? Well, whenever you are solving a function with a number inside, you just replace x with that number. So I'm going to rewrite g of x, which is the square root of x plus 1. But instead of x, I'm going to write 5, which is the number in with the parentheses. And now we can just solve this. So 5 minus 1 is equal to 4. And the square root of 4, well, that's what number you multiply twice to get 4, which is 2. So 2 times 2 is 4. The square root of 4 is 2. Now remember, that's not our answer because that just tells us what g of 5 is. So if g of 5 is 2, then this is the same as f of 2. So now we have to figure out what f of 2 is, and that's going to give us our answer. So what is f of 2? Well, for this one, we're going to use f of x, not g of x, right? Because we used g last time. So f of x is 3x minus 2. We're going to rewrite 3x minus 2, but instead of x, we're going to put the number 2. So it's going to be 3 times 2, because we're replacing x with 2, minus 2. And now we can just solve this. So 3 times 2 is 6, and then 6 minus 2 is 4, which means that our final answer for the composite function is 4, and that is the letter A. Okay, let's move on to some geometry. For this, you need to just understand how different shapes work, how angles work, and things like that. And for this one, it looks like we need to know how triangles work because it says the vertex angle of an isosceles triangle is 30 degrees. And we have to find the measure of a base angle. So this is a lot of vocab, and honestly, since yesterday, I don't think I've ever heard it called the vertex angle. Maybe I've heard it called the base angle, but really I want to show you that you don't need to know what those words mean to be able to figure out the problem. The key word that you do have to understand is isosceles. An isosceles triangle is basically where you have two sides that are the same length and then a third side that's a different length. And the key thing is that's also true for the angles. You have two angles that are the same size, and then you have another angle that's a different size. So I'll just draw an example of an isosceles triangle. It's going to look something like this. I mean, this is a terrible drawing, but just roll with it, all right? So basically, you're going to have two angles, like this one and this one, that are going to be the same size. And then you're going to have this one up here that's going to be a different size. I'll put two little arcs to show that. So just based on this information, we can kind of try to figure out what these other words mean. Like when it says the vertex angle is 30 degrees, like the vertex angle, as in there's one of them. So I have a feeling that's going to be this one. I mean, I've never heard it called the vertex angle before, but it makes sense. It's saying that the angle that's by itself is 30 degrees. And here it says, what is the measure of a base angle, suggesting that there are multiple of them. And here are the two base angles right here. So how do we find the measures of these angles? Remember that they're going to be the same angle measure because it's isosceles. And you have to know one more thing about triangles. You need to know that every triangle, all of the angles inside of the triangle add up to 180 degrees. This is true for every triangle. So we could write this as an algebra problem, but like, who wants to do that? So let's just think this through logically. We have 180 degrees total, but this angle up here is taking up 30. So what does that leave for the other two angles? Well, 180 minus 30 is 150. So there are 150 degrees left for these two angles. And we know that these two angles have the same angle measure. They're exactly the same. So how do we distribute 150 degrees evenly between the two? Well, we just divide it by 2. 150 divided by 2 is 75, which means that both of these angles are 75 degrees. And it says, what is the measure of a base angle? In this case, that's 75. So the answer here is D, 75. Okay, this next category is pretty different from the rest of them, but it's still really important to know, and that is statistics and probability. And I feel like a lot of students struggle with this, but if you just keep practicing this, then I think it'll start to feel really logical to you. But let's take a look at this problem. It says that Bob has a drawer with 10 socks that make up 5 matching pairs. So just think maybe five pairs of socks, and each of them is like a different color, right? So he randomly pulls 2 socks out of the drawer and puts them on. And we have to find the probability that he has picked a matching pair. So basically, he picks the 2 red ones or the 2 blue ones or whatever. I don't know how crazy his socks are. So I know this just looks like one thing that he does that we have to find the probability of, but really he's doing 2 different things. He's pulling out his first sock, and then he's pulling out a second sock, right? So we have to find the probability for both of those. Now, what you want to do is each time he does an event, you want to find the probability that it disqualifies him from completing this, right? Like if he pulls his first sock and now it's impossible to complete the challenge, then it's going to, affect the probability. So what is the probability that when he chooses the first sock that it disqualifies him from picking a matching pair? And the answer is, well, there is no probability of that, right? No matter which one he chooses, he still has a chance of picking a matching pair because every color has a matching pair, right? So his odds of staying in the game are, I guess, 10 out of 10. But really, you can just ignore this fraction because it doesn't even affect the probability. What we do care about is the second sock because that's going to determine if he's picked a matching pair or not. So it really doesn't matter which one he picked first. So let's just say that he picked a red one first, right? He picked a red sock. So now, what is the probability that the second time he picks another red sock? Well, there were 2 red socks in the drawer and 10 total. So you might think that it's 2 out of 10. But actually, remember that he pulled out one of the red socks already. So there's only one more left in the drawer. So there's only one sock he can pick that will complete this challenge. And how many are there in total? Well, there were 10, but he already pulled one out. So now there are only 9 left, which means that the bottom of our fraction is going to be 9. His chances are 1 out of 9. There are 9 possibilities, and only one will complete the challenge. And remember that we can just ignore this fraction because it's just equal to 1. It's guaranteed. So the only probability we care about is 1 out of 9. And that is answer choice A. Those are the chances that Bob succeeds in picking a matching pair. Or he can just actually look in the drawer and not pick them out randomly. That works too. So those were the 5 types of problems, but you might be wondering why there's like 3 more minutes in this video. And that's because there's one more secret type of problem that the ACT makes you do, and it's called integrating essential skills. So integrating essential skills is basically just where you take everything you've learned from previous categories and applying them to one problem. Or it makes you take a previous type of problem and then use it in a way that you haven't really thought of before. Basically, this is just where they put all of their weird problems. So this is an example of a weird problem, right? It says that given that 1 is less than or equal, I don't know what's going on, what is the greatest possible value? That's the important word here, right? The greatest value for A over B times 1 over C. This is multiplication because there's no sign in between. So I'm just going to write these fractions out because I think it'll be easier to see this way. We have A over B times 1 over C. And you'll notice that when we multiply fractions, we just multiply the tops and the bottoms. So this is eventually going to become one big fraction, A times 1, B times C. So how do we find the greatest possible value? And what is even going on up here? Well, don't get confused by all of the crazy signs and stuff. This is basically just saying that A is in between 1 and 3. Because remember that the alligator chomps the bigger number. So it's chomping A instead of 1, so A must be bigger than 1 or equal to it. That's what the little line means. But the alligator would rather chomp 3 than A, so A must be less than 3 or equal to it. So A is anywhere from 1 to 3. Same with B, it's anywhere from 2 to 4, and C is anywhere from 5 to 7. Unfortunately, not 6 to 7. That's not funny. Okay, I'm going to move on. So what do we do? Just test every single combination of numbers and then just see which one's the greatest? Well, first of all, that would take a really long time. Second of all, you can't even do that because there are infinite numbers between 1 and 3. There's 2.7, there's 2.8, right? So what do we do then? Well, our next thought might be, because we want the greatest possible value, why don't we just take the biggest numbers out of all of these and use those? Wouldn't that give us the biggest value? And the problem is that bigger numbers for the letters might actually make the whole thing smaller. So what we have to do is we have to look at this fraction, turn on our like math brain cells or whatever. I don't know if I have any. And then we have to ask ourselves, would each letter be better if it was bigger or smaller? And actually, we can just use either the smallest or biggest number. So like, for example, for A, we can just use either 1 or 3. It's not going to be something like 2 because it can always benefit from either going in the bigger direction or the smaller direction. So why would we go down the middle, right? We either want to go all the way to the 3 or all the way back to the 1. So let's look at each letter individually. Let's look at the letter A. Should the letter A be as big as possible or as small as possible to get the greatest possible value for this fraction? Well, when you increase the top of a fraction, it makes the whole fraction bigger, right? Like 3 over 5 is better than 2 over 5. 3 slices of pizza is better than 2 slices. So we want A to be as big as possible. So we're going to put the number 3 for A. That's the biggest it can be. What about the letter B, right? Do we want that to be as big as possible? Well, B here is at the bottom of a fraction. And when you increase the bottom of a fraction, that would be like cutting up a pizza into more slices. You might think that more slices is good, but it's the same pizza. So when you get 2 slices of pizza, then that means the slices are smaller. So it's actually less pizza. So we don't want B to be larger, because the larger that B is, the less of the value of the full fraction. So we actually want B to be as small as possible. And in this case, the smallest number it can be is 2. And that's actually the same thing for C. C is also at the bottom of a fraction. We want that to be as small as possible. And the smallest number that C can be is 5. So we've found the 3 numbers that we need. Let's go ahead and replace these letters with the numbers that we've solved for. And when we do that, we now have a fraction multiplication problem. And now we can just multiply the tops and multiply the bottoms. So 3 times 1 is 3, and 2 times 5 is 10. Which means that our greatest possible value for the fraction is 3 over 10, and that is answer choice B. The math section is possibly the scariest part of the ACT exam, and some people even say that it's harder than the SAT's math section, but you don't have to worry about it because you clicked on this video and you're going to be prepared. So here are 5 practice problems that will help you absolutely destroy and obliterate the ACT math section. So here's the first example that we'll be doing. It says if x equals 2 and y equals 4, what is 3x squared minus y squared? So remember that whenever an algebra problem tells us that two things are equal to each other, we can replace them with each other in the equation. So for this, we're just going to take these letters because we can't really do math with letters, right? But it tells us that they're equal to numbers. So we can just replace these letters with those numbers. We were told that x is equal to 2, so we're just going to replace x with 2. And we're putting it in parentheses because if you didn't put it in parentheses, then it would say 32, and it's not 32, right? And then we know that y is 4, so we're going to replace y with 4. And now our math problem here is entirely with numbers. There's no letters in it, so we can just solve it like a normal math problem. And remember that according to PEMDAS, which is just the order that you should do things in, we don't have anything inside of parentheses, but we need to do exponents before we do anything else. So these two things are exponents here. So let's solve our exponents. So the 3 stays the same, and then 2 to the 2, or 2 squared. That means 2 times 2, which is 4. And then minus, and here we have 4 squared. That means 4 times 4, which is 16. So we've solved our exponents, and now we need to do our multiplication and division. We only have one multiplication here. It's right here. And 3 times 4 is 12. Now, all we have left here is subtraction, and it looks like we're going to be getting a negative number, which can be pretty confusing. Now, you do get a calculator on the ACT, so if this confuses you, you can just put it in your calculator and it'll give you the answer. But I feel like a good way to look at these kinds of problems is to think of it as money. So, for example, let's say you earned $12 and then you spent $16 on something. Well, in this case, if you earned 12 and then lost $16, you've lost a total of $4, right? So yeah, negative 4 is the final answer to this problem. Now, the ACT and the SAT as well, if you take that, are going to have a lot of word problems. And word problems often don't take any more complicated math. Sometimes it's even easier, but you have to know how to apply it from a real life situation. So here we have a car that's averaging 25 miles a gallon, and a gallon of gas costs $3.80. So how much would it cost to drive the car 2,000 miles? So here I've written down the 3 important pieces of information that we have. So how can we use this to solve our problem? Well, I feel like the thing that trips up a lot of students with word problems is they think they need to come up with some magic, like super hard, complicated algebra equation to represent the situation. But sometimes you don't even have to write out a formal equation. Sometimes it's better to just think about it logically, like you would solving a normal math problem in your everyday life. So we're trying to find how much money was spent in total, but we already know how much a gallon of gas costs. So, what kind of information do you think would be really useful here? Well, if we know how much a gallon of gas costs, I think it would be also helpful to know how many gallons we're using, because then all you have to do is take the amount of gallons, multiply it by $3.80, and we'll have our final total. Just like if you went to the store and cereal boxes were $5 and you bought 4 of them, you would do 5 times 4. So, how do we find out how many gallons we used? Well, we know that for every 25 miles we drive, we're using up 1 gallon. And we know that we've driven 2,000 miles. So, using just kind of the logical part of the brain that's used to solve math problems in everyday life, how do you think we'd figure out how many gallons we used? Well, if we divide 2,000 miles by 25 miles per gallon, and remember that you can just put this in your calculator, you don't have to do this in your head. But 2,000 miles divided by 25 miles a gallon, 2,000 divided by 25 is 80. So we can say that we've used 80 gallons of gas. And if you're not sure that you did that right, you can just kind of think about it logically. Does it make sense that on a 2,000 mile drive, we used 80 gallons of gas? I mean, that seems like a kind of reasonable number, right? So we know that we've used 80 gallons, and we know that a gallon of gas is $3.80. So to figure out how much money we've spent, we'll just multiply them together. So we'll take 80 times $3.80. And if you put this in your calculator, you should get 304. So there we go. We figured out how much money we've spent in total. We've spent $304 on gas for this trip. Now, from looking at different ACT practice tests and stuff, I've noticed that they really like to test you on geometry. And it's another word problem. So let's take a look. It says that Super Cool High School is located 6 miles east and 8 miles north from your house. How far is it away from your house? So whenever we come across these geometry-based word problems, what we need to do is draw a diagram. And yeah, I know that drawing a diagram seems kind of cheesy and sometimes it's pretty pointless, but in this case, I think it's going to be really useful. So first, let's draw our house because that's an important part of this problem, right? So let's go ahead and draw a little house. So there's me, right? Give myself a little smiley face. Awesome. Don't do this on the ACT. It's a waste of time. So then let's just go ahead and draw what we know. So we know that Super Cool High School is 6 miles east. So let's just go ahead and draw a little arrow going to the east, and then we can just label this as 6 miles. So we know that it's 6 miles this way. And now it says that it's 8 miles north. So we need to go 8 miles up, and then we can just label this 8 miles. And then here we have our school. So let's just go ahead and draw a little school. I mean, not gonna lie, this kind of looks more like a castle than a school, but maybe your school is a castle. I don't know. So the question's asking how far away is our school from our house? Well, you could just say, okay, well, 6 plus 8, right? We gotta go 6 miles this way and 8 miles this way, so it's 14 miles. No, because there's actually a faster way to get to the school, and that's by just going straight there. So we'll draw another arrow here that shows that we're going straight from our house to the school. And remember that when we don't know a number in algebra, we use a letter instead. And our favorite letter in algebra is X. So we're going to put X here. And this is what we're trying to find. We're trying to find the length from our house to our school on this diagonal line. Now, if you remember from geometry, this little setup here should look pretty familiar. When you have a triangle here, and specifically a right triangle is when one of these angles is exactly 90 degrees, right? It's got like this, you could put a little box here basically. Whenever you have a side missing from a right triangle, we can use something called the Pythagorean theorem. Now, if you don't already know the Pythagorean theorem, it basically says that a squared plus b squared equals c squared. Well, that's pretty pointless if you don't know what the letters actually mean, right? So it's important to understand the formulas as well. So a and b just represent sides of the triangle. So in this case, we can call those 6 and 8. But the important part is that c is always the longest side. It's always the diagonal side as well. So this diagonal side is going to be c. And then these are going to be a and b. It doesn't matter which. So if we plug in what we know for a and b, we can solve for c and find out the length of this side. So we'll just call this one a. So a is going to be 6. So 6 squared plus, and then we know that the other side is 8. So it's going to be 8 squared equals c squared. Or in this case, we're going to call it x because that's the number we're looking for. And now if we just simplify this down, we can figure out what x is. So 6 squared, that means 6 times 6, which is 36. And then 8 squared, that's 8 times 8, which is 64. And then the equals x squared just stays the same. So 36 plus 64, you can put that in your calculator, you'll get 100. Now we've simplified this as much as we can, but we need to solve for x, which means getting x by itself. And the only thing that's stuck to this x right now is this square. So what's the opposite of squaring? Well, the opposite is square rooting. So if we square root both sides, then we can get x by itself. So the square root and the squared cancel, and we just have x equals the square root of 100. So what number can you multiply by itself to get to 100? Well, if you didn't know this, you could put in your calculator as always, but the square root of 100 is 10. And technically, negative 10 could work as well, but you're not going to walk a negative distance to your school, so we're going to use the positive amount. So there we go. We've solved the problem. Our house is 10 miles away from the school. Now, a pretty common type of problem on the ACT is something that looks like this, kind of a geometry thing with a bunch of lines and degrees and letters, and it can seem really confusing. But if we take things one step at a time, then we can just use a couple geometry rules to figure out the answer. And as I'll show you, sometimes you don't even actually have to know specific geometry rules to solve these kinds of things. So the important thing to know, first of all, for these kinds of geometry problems is what these letters and stuff even mean. So it says that we need to solve for angle CAD. Now, what does that even mean? Well, to figure out what angle we're talking about, we basically just need to connect the dots. So if it says angle CAD, then we're going to start at C, we're going to draw a line to A, and then we're going to draw a line, and then we're going to draw a line to D. And this is the angle we're talking about here. And usually it's the letter in the middle, so CAD, A is in the middle. That's usually where the angle is located. So we're solving for this angle right here, and we're going to go ahead and put an X there to represent that. So there's actually two different ways that I can see that we can solve this. So if you want to try to figure out at least one of those ways, then you can pause the video and see if you can figure it out yourself. So the first thing that I'm seeing is a rule about parallelograms. And we can know it's a parallelogram because these lines are parallel. That's why it's called a parallelogram. Now, these little tick marks here, these little dashes in the lines, those represent being parallel. So these two lines that both have one little tick mark, though, that means that those are parallel. And then the ones with two tick marks, those are parallel to each other. And if we have a parallelogram, then one of the rules here is that if two angles are next to each other, like this one and this one, or this one and this one, they are going to add up to 180. So we know that this angle and this angle, which by the way includes both the x and the 50, is going to equal 180. So to figure out what this section is, first of all, we need to take 180, which is our total amount of degrees. And if we subtract the 70, then 180 minus 70, if you put that in your calculator, you're going to get 110. So what that tells us is that if this angle here is 70, then this angle needs to be 110 to make them add up to 180. But remember that we're solving for x, and x is just this section of the angle here. So we know that this whole thing is 110, but this part is 50. So what is the other part going to be? Well, we can do the same thing. If the total is 110, and this part is already taking up 50 of it, then the other part is going to take up the remaining section. 110 minus 50 is 60. So we know that x here has to be 60 degrees. And that's our final answer. Now, there's another way that you could have solved this, and that's using another rule. Now, the other rule is that because this line here is going in between two parallel lines, it actually means that this angle and the other angle on the other side of the line have to be equal to each other. So this has to be 50 degrees. And all the angles of a triangle have to add up to 180. So we have 180 in total in this triangle here. By the way, I'm talking about this triangle. This angle here is taking up 70 of them, and this angle here is taking up 50 of them. So all that's left for this angle here is 180 minus 70, which is 110, minus 50, which is 60. Now, if you didn't know all of those geometry rules I just spat at you, that's totally fine. You don't have to remember all the rules. But you might have noticed something in common with them. You probably noticed that pretty much every single rule that I just listed has to do with angles adding up to 180 degrees. And there are also a lot of geometry rules that add up to 90 degrees. So I would say that 180 and 90 are like the magic numbers of geometry. If you're not sure what a rule says, then it probably is saying that things add up to 180 or sometimes 90. So yeah, it's important to know these different geometry rules like triangles adding up to 180 and things like that. So definitely look at some more geometry practice problems so that you can get a feel for what kinds of things they expect you to know. Now, enough of the geometry. Here's one more final practice problem, and this is going to be sort of algebra, but really it's just going to be logic and working backwards. So we see that John's bank account on his 17th birthday had $200 more than on his 16th birthday. And we also know that today, which is his 18th birthday, his money is doubled from before. But notice how it doesn't give us his money at the start. It gives us his money at the end. So for example, let's say he had $100 on his 16th birthday. Let's say that the problem told us that. Well, to figure out how much he had at the end, all we need to do is do each of these steps. So on his 17th birthday, he added $200. So now he has 300. And then from the 17th birthday to his 18th birthday, it doubled. So it doubles from 300 to 600. And our final answer would be $600. Well, instead, in this problem, they've decided to give us the final amount, which they've told us is $700. And we need to figure out what he had on his 16th birthday. So to do this, we just need to work backwards from what it gave us to figure out the initial amount, the starting amount. So what number do we need to double to get to $700? That might be a little bit harder to figure out, but really all you have to do is do the opposite of doubling. Remember that doubling basically just means the same thing as multiplying by 2. That's what you're doing, right? So what's the opposite of multiplying? Well, it's dividing. So if we divide by 2, we'll get our first number. So if you put this in your calculator, 700 divided by 2 is 350. So we know that initially, before he doubled his money, he had $350. And if you weren't sure, you could do it the other way. You could take 350, multiply it by 2, and if you get 700 again, then you did it right. So we know that he had $350 on his 17th birthday. But what did he have on his 16th birthday? Well, it looks like he added $200. So to work backwards and figure out what he had at first, we'll do the opposite of adding, which is subtracting. So we'll subtract $200. So we had 350 minus 200. And if you put that in your calculator, you would get 150. So John had $150 in his bank account on his 16th birthday. I've been watching some ACT advice videos recently, and it pains me every single time I hear people say, this is the best guessing strategy, or always guess the letter E because it's the most likely letter. How about this? Instead of telling you how to guess better, I show you how to actually get problems correct. Here are my favorite ACT math strategies that actually work. This first tip honestly might be the secret to getting good at any kind of math. Let's look at this problem as an example. We basically have to find the missing side here of this triangle. So to solve this problem, you're supposed to recognize that this is a right triangle, and so you can use the Pythagorean theorem. A squared plus b squared equals c squared. Then you just plug in the numbers, so 9 squared plus b squared equals 15 squared, and then you're just supposed to solve for b in the equation. So let's say that you didn't know what this was. You didn't know that you were supposed to use the Pythagorean theorem. Well, then you're probably going to get this question wrong. But you would only get this question wrong. But let's say that you didn't know how to do this problem because you couldn't solve for x at the end. Well, then you're going to get this problem wrong, and this problem wrong, and this problem wrong. So what this means is that before you start studying little things like the Pythagorean theorem, you need to make sure you know the fundamentals like solving for x, how graphs work, how to simplify expressions, and so on. If you're not sure what to study, I actually found this pretty helpful Reddit post that has the 15 topics that are guaranteed to be on the ACT. So that'll be in the description if you want to look at that. So tip number 1 is that you have to know the fundamentals. Now let's say that you're taking the test and you get a problem that you didn't study and you just have no clue how to do it. Well, you're not just going to blindly guess. Instead, there may be more than one way to solve the problem. Let's look at this problem. It says, which of these is a solution to the equation x squared minus 5x plus 6 equals 0? Well, this is a quadratic equation, and usually there's multiple ways to solve a quadratic equation. But let's say that you don't remember any of them and you have no clue where to start. Well, what most students will do when they see a problem that they have no clue how to solve is they'll just guess a random letter. Maybe I'll just guess C because I always guess C when I don't know the answer. Well, before we just guess blindly, we first want to see if there's another way to solve the problem. And one of the most common ways to alternatively solve a problem is to go from the answers to the question and test out the answers. So for example, if I wanted to test if A is the right answer, I could just plug in 1 in for x. So this equation would become 1 squared minus 5 times 1 plus 6 equals 0. And then I just solve the equation to see if it equals 0. So 1 squared is 1, minus 5 times 1 is 5, plus 6. 1 minus 5 is negative 4, plus 6 is 2. and that does not equal 0. So we know that A can't be the answer. Let's try B now, which is 3. So if I plug in 3 for x in this equation, then we get 3 squared, 3 times 3 is 9, minus 5 times 3, which is 15, plus 6 equals 0. 9 minus 15 is negative 6, and negative 6 plus 6 equals 0. So we didn't even solve this problem the way we were supposed to, but by working backwards, we figured out that the answer is B, 3. So sometimes instead of actually answering the question, you can just work backwards to figure out what the answer is. Now, one of the most stressful things about taking the ACT is the time limit. So to save a little time, what if I told you that you don't always have to solve the entire problem? So for this problem, it says that we need to find the solution to this system of equations. And because there are two numbers, there's a pair of numbers in each answer choice. That means we're probably going to have to solve for both x and y. Now, there's two ways to solve systems of equations. There's substitution and there's elimination. And it looks like they want us to do elimination here because the plus 2y and the minus 2y, those just cancel out. And we'll add together the rest of the equations. So x plus 3x, that's 4x, and then that's going to equal 3 plus 5, which is 8. And now we just have a one-step problem, so let's go ahead and solve for x. This is multiplication here, so I'm going to do the opposite of multiplication, which is division, and divide both sides by 4. And this is just going to leave us with x equals 8 divided by 4, which is 2. Now, the next step of a system of equations is to plug in x equals 2 into either equation and solve for y. But wait a minute, let's look at our answer choices again. A and B say that x is equal to 1. D says that x is equal to 3. The only one that says that x is equal to 2 is answer choice C. So we don't even have to solve for y. We know that the answer has to be C. Now, obviously, it would be better if we then solved for y just to make sure it's 1/2 and to make sure we did the problem correctly. But if you're running out of time and you've still got a lot of problems to do, checking your answer with y would take too long. So just pick C and move on. So when you're solving a problem, check to see if you don't need to do the entire problem to figure out what the answer is. Now, let's say that you get a problem that you're really stumped on, and none of the strategies that we've talked about so far will work for this problem. Well, you could just guess that ACT actually recently reduced the amount of options for a math problem from 5 to 4. But that's still only a 25% chance. So let's try to improve those odds just a little bit. Maybe even do 100%. Here's another example problem where we have an imaginary number problem, and we need to simplify this square root thing. Now, if we absolutely don't remember how to do this, we're not just going to guess from these 4 choices. We first need to see if we can eliminate some of them first. And the thing that you have to understand is that the question writers don't just pick the wrong answers randomly, like from a random number generator. They're trying to pick answers that they think you would accidentally get as your answer. So personally, I find it fairly suspicious that we have 3 plus 2i and 3 minus 2i both as answer choices. It kind of suggests that they're going to want us to pick between a plus and a minus. And if we look at this further, over here we have a 5 in both of these. And I mean, the square root of 9 is 3 and the square root of 4 is 2. So they're trying to bait us into thinking that we're supposed to just add these two square roots together. But if you think about it, we know that the square root of 9 is 3. And that's not an imaginary number, right? That's not going to have an I in it. So why would our final answer only have an I in it? Like, that's just an imaginary number. We know that our answer needs to have the real number 3 in it. And so I can eliminate choices A and B. And looking at these two answer choices might be enough to jog your memory about how we do this. I mean, to me, it looks like because we have a plus sign here and we have a plus sign here, the answer is probably C. But even if you didn't know that 3 plus 2i was the answer instead of 3 minus 2i, well, just eliminating those first two answers brought our guessing chances up to 50-50. Another example of this might come if, for example, we were doing a distributive property problem. I guarantee you that if you saw this on the test, one of the answer choices would be something like 5x plus 7y, because they want you to think that you're supposed to add 3 plus 2 and then 3 plus 4. But that's not what this is. There is no addition sign here. Whenever you have a number next to something else in algebra, that's multiplication. So we can immediately eliminate answer A. So if you're not sure of what the answer is, start thinking like the question writer and see if you can eliminate some of the obviously wrong answers. Now, we've gone over a lot of tips and strategies that you can use on test day. But really, there's only one way to guarantee that you'll be prepared for the ACT. A lot of students will just go and watch videos like this one, looking for some sort of hack or strategy that will change the way that they take tests. But they'll never actually see what an ACT problem really looks like until they take the test. So the number one best way to prepare for the ACT is to do practice problems, do more practice problems, and do even more practice problems. The more real problems that you do, the more you'll start to see patterns that you can use on test day. But it would be even better if you had these problems explained to you after you tried them so that you can learn from your mistakes. If only there was some sort of YouTube video out there where you could do that. For a lot of people, the math section is the scariest part of the ACT exam. But as long as you prepare for it beforehand and practice, you won't have to worry about it. So it's a good thing that the kind people of the ACT have provided us with this. This is the ACT's official math practice test. Why are we in Chuck E. Cheese, bro? So I'm basically just going to explain everything that I'm doing for these problems so that you'll be ready for the test. And I haven't seen any of these questions before. Well, except the first two. But other than that, I'm going into this blind. So let's see how this goes. 6-7. 6-7. Okay, it's fine. Calm down. 6-7 isn't funny. Okay. So it says that Cameron took 4 tests, and those were his scores: 100, 60, 80, and 30. And then he took another test that was scored X, and it tells us the mean score. It says that out of the 5 tests, he got a mean score of 72. So we have to basically just find the missing test. So remember that a mean is basically just the same thing as an average. So the average score on these tests was 72. Now, whenever you have something that says we need to like solve for X, even if it's in a word problem, that usually implies that we should be doing some sort of algebra, right? So how do you find an average? Well, you always add up all of the numbers and then you divide it by how many numbers there are. So I'm basically just going to write out as an algebra problem how we would find the average. So we're first going to add up all of the test scores. So Cameron got a 100 on his first test, then he got a 60, and then he got an 80, and then he got a 30. These are some wild test scores. And then X for the 5th one, because we don't know what the 5th test score is. That's what we're trying to find. And then once you've added up all of the test scores, we would divide it by how many tests he took, which he took 5 of them. And we know that the average is going to be equal to 72. So now we basically just need to solve for X, and we can do that using algebra. And we need to get X by itself on this side of the equation. So X is trapped at the top of this fraction, but we can just get rid of the fraction because fractions are just division. So I'm going to do the opposite of division, which is multiplication, and multiply both sides of the equation by 5. So these cancel out. And on the left side, we just have, well, this big thing. And on the right side, we have 72 times 5. And if you were to put this into your calculator, you would get 360. So now that we've gotten the fraction out of the way, it's a lot easier to get X by itself. But this equation still looks kind of complicated. But all of these are just numbers that I can add together. I guess you could call them like terms. So why don't I just add all of these together? So 100 plus 60 is 160, plus 80 is 240, plus 30 is 270. So all of this together makes 270 plus X equals 360. And I'm going to go ahead and erase this because I'm running out of room here. So the only thing in X's way now of being by itself is this 270. And it's being added to X. So I'm going to do the opposite of addition, which is subtraction, and subtract both sides by 270. So these cancel out. On the left side, we just have X, and on the right side, we have 360 minus 270, which is 90. So this means that Cameron's final test score was a 90. Okay, so for this one, we have a Venn diagram. So we have S, C, and P, and those are basically just the 3 different animals that this farmer has, and we have to figure out how many farms represented do not raise cows. Well, this question might actually be a lot easier than you think. You see that there's like a bunch of different numbers, but if you think about it, just all of the numbers inside of that C circle are the ones that raise cows. And all of the ones that are outside of the C circle do not raise cows. Those 2 other circles with the S and the P, that's just useless information because all it's asking us about is cows. So who cares if they raise sheep or pigs? So it looks like outside of that C circle, there's a 12 in there. That 12 is only in the S circle. So that is a farmer that only raises sheep. And then it looks like there's also a 2 outside of the C circle that raise both sheep and pigs. And then there's a 5 that's outside of the C circle. They only raise pigs. But you didn't even have to know that. You just have to know that they're outside of the C circle. All of those other numbers on there are inside of it. So let's just add these together. 12 plus 2 is 14. And 14 plus 5 is 19. So it looks like there are 19 farmers that don't raise cows. Okay, this one looks like it has a lot of words. You're going to be seeing a lot of word problems on the ACT. So I'm going to get my head out of the way. So it says that Marco designs a spinner wheel that has exactly 4 red, blue, green, and wait, what? Exactly 4 red, blue, green, and yellow. What? I think it's just saying that there's a red section, a blue section, a green section, and a yellow section. I think that's what it's saying. I guess this is what I get for trying to do a practice test that looks like Chuck E. Cheese. And it says that he wants the spinner wheel to have a 25% chance of landing on each section. So basically, each one needs to be equal. So whenever you see one of these kinds of problems, I want you to envision this in your head. I want you to imagine a spinner wheel, kind of like a little pie chart, and a quarter of the circle, a quarter of the spinner is each color. And that's his goal. That's what he wants. And it says he spins the wheel 500 times, and those are the results of the spins. Based on the results in this table, one of the following changes would be the best fix. Which one? Okay, so let's see our answer choices. It says he should decrease the area of the red section by increasing the area of the blue section. Well, if we think about that logically, red was the one that got spun the least, so why would we decrease that? Then you would make it even worse, so let's not do that. He should increase the area of the red section by decreasing the area of the blue section. Okay, I mean, I feel like that's possible because red is the worst and blue is the best, so we could take away some blue and add some red. He should increase the area of the red section by decreasing the area of any of the other 3 sections. Well, if we're going to decrease one of the other sections, we should probably do it with the one that got landed on the most, because that's probably the biggest one. And then he should decrease the area of the blue section, and then it does not matter which section's area is increased. Now, it matters because red is the smallest one. So basically, it's implying that we should change the wheel. It's not like don't change the wheel as an option. So to me, it seems like if we are going to change this, the best choice is to add to the smallest one and take away from the biggest one because you're trying to make them as equal as possible. So I think that the best fix for this is going to be that we increase red, our smallest one, and we decrease blue, which is our biggest one, and that'll make them as equal as possible. All right, oh, we've got some geometry. All right, angles. So it says that in triangle ABC, so I just want you to imagine a triangle right now, angles A and C are congruent, and the measure of angle B is 143.6. What is the measure of angle A? Okay, so for this, we need to know a couple geometry things that if you don't know them, if you're not aware of them, then this might be a little bit tough. First of all, it says that angles A and C are congruent. So basically, when 2 angles are congruent, that means that they have the same angle measure. So the measure of angle A is going to be equal to the measure of angle C. Don't get confused about these M's. The M just stands for measure. So it basically just means we're talking about the amount of degrees and not about the actual angle itself. So the second rule about triangles that you should always know is that all 3 angles of the triangle are going to add up to 180 degrees. So if we take 143.6 and then we add together angle A and angle C, then they should add up to 180. So we can solve this using algebra just like the first problem, but it might seem kind of weird because we have 2 letters that we need to solve for. And normally when you have one equation, you can only solve for 1 letter. But remember that we were told that because A and C are congruent, they are going to be equal to each other. So how about we just replace A and C with X? It doesn't matter what letter you use, but we can show that these two are going to be the same number. So we can use the same letter for both of them. They're equal. And whenever you have 2 terms with the same letter, those are like terms, and you can actually combine them. So x plus x is going to turn into 2x. And when we just rewrite the rest of the equation, just keep it the same, then you'll notice that this is an algebra problem with just 1 letter. And we didn't have to use x. You could have actually just erased c and replaced it with a because c is equal to a. You can use whatever letter you want, but the point is that you can combine them into 2 times x. So now let's go ahead and solve for x. We have a 2 multiplied to x and a big number added to x. And usually you want to get rid of the addition and subtraction first. So I'm going to get rid of this 143.6 by subtracting it from both sides of the equation, the opposite of addition. So these cancel out. On the left side, we just have 2x And on the right side, we have 180 minus 143.6. I'm just going to put that in my calculator. And when I do that, I get 36.4. And now we just have a one-step equation. So this is multiplication whenever you have a number next to a letter. So I'm going to do the opposite of multiplication, which is division, and divide both sides by 2. So these cancel out. On the left side, we just have x. And on the right side, we have 36.4 divided by 2, which you can put that in your calculator as well. You'll get 18.2. And that is one of our answer choices. So the answer is going to be 18.2. Now, one thing to keep in mind here is that before we even started this problem, you probably could have noticed that 143.6 is not going to be the answer because it needs to add up to 180. So that is way too big. And these other ones are actually all way too big. So even without doing that math, you could have figured out that it was 18.2. Okay, we've got some algebra here, some factoring. So which of the following expressions is equivalent to x squared minus x minus 30? So you'll notice that those answers in the top right are two sets of parentheses, and each one is x plus a number or x minus a number. So whenever you see that, you should be like, that's factoring or that's FOIL. It depends on which way you're going. But when we're going from the quadratic equation at the top there to the parentheses format, it's the opposite of FOIL. So we call that factoring. So to factor a quadratic equation, we basically are just going to need the number in front of x and the number that's by itself. And make sure you always include the minus signs. Now there's no number in front of x, but that means that there's an invisible 1. So it's actually going to be -1. -1 in front of x and -30 by itself. So we need to find two numbers that add up to -1 and multiply to get -30. So let's run through those numbers. I always like to start with the numbers that multiply to 30 and then figure out what they add to. So what numbers multiply to 30? Well, there's 1 and 30. That's the obvious one. And remember that it's -30. So one of these numbers is going to have to be negative. We're always going to put the negative sign on the bigger number because we're adding to a negative number. So if we were adding to a positive number, then I would put the minus sign on the 1, the smaller number. So these multiply to -30, but if you add them together, 1 minus 30 is -29. That's definitely not what we're looking for. What about 2 and 15? Those multiply to 30. Again, we're going to put the minus sign on the bigger number so that we'll add to a negative number. And 2 minus 15 is -13. That's still not what we're looking for, but we're closer. Now, also 3 times 10 is 30. Again, we'll put the minus sign on the bigger number. And 3 minus 10 is -7. We're closer, but still not -1. The only other factors of 30 are 5 and 6. 5 times 6 is 30. We have to put the negative sign on one of them, so we'll do it on the bigger number. And 5 minus 6 is -1. And -1 is the number that we're looking for, so 5 and -6 are our magic numbers. Now, the last thing we have to do with our magic numbers is we just put them in parentheses with x's. So we have two sets of parentheses with x's. One of them is going to have +5, and one of them is going to have -6. So now let's go ahead and look at our answer choices. None of them look exactly like what we just came up with, but this one right here is exactly the same as our answer, except they just decided to flip the two sets of parentheses. But remember, it doesn't matter what order you multiply in. This answer here is wrong because this is +6 and -5. So those would multiply to -30, but they add together to make +1. So this right here is our answer for question 5. Oh boy. Okay, we have matrices. Oh boy. Now here's the thing about matrices, right? If you haven't gone past like algebra 2 or geometry, you might have never seen matrices in your life. So you might be tempted to just go ahead and skip this problem. But it's on the ACT for a reason, and I feel like this is possible to just wing it. Like, come up, what do you think is the most reasonable answer? Now, there's only two of those answers that are actually the same size of a matrix, because that's like a 2x2 one up there. But two of the answers aren't even 2x2s. So we can actually just get rid of these two answers up here. So now which one just seems the most reasonable? Well, remember that when you have a number next to something without a sign, that means multiplication. And I don't even, what is the third option there? What is C? I don't even know what's going on. Oh, it looks like they're adding them together. So part of this is even if you don't know how to do the problem, you can try to figure out where the wrong answers are coming from, because the test writers, they were trying to make answers that you might reasonably come up with. And for answer C, they're just adding together the numbers. But we know that this is multiplication because they're next to each other without a sign. And for the fourth option, it looks like they are multiplying it together, because 5 times a -4 is -20, or 5 times 2 is 10. So to me, it looks like D is the most reasonable answer. And in fact, that is actually how you do matrices. Whenever you're multiplying it by a number, you just multiply all the numbers inside the parentheses or inside the matrix, whatever, same thing. Okay, final question here, and it's a word problem about Lavon. So Lavon purchased some tickets and snack vouchers for an upcoming event and gave them to the members of her work group. Each member of her group received the same number of tickets and the same number of snack vouchers. So again, I just want you to picture in your head a group of people, and they're all getting tickets and vouchers passed out to them, and they're all getting the same amount. The total number of tickets was 30, and the total number of vouchers was 75. So which of the following could be the number of members in the work group? So whenever you see which of the following could be the total number of members, I think usually this means there's like two possibilities. So one possibility is that it's an algebra problem and it's like an inequality. So for example, you would solve the algebra problem and then it would be like x is greater than 3. And then you have to pick out the number that's greater than 3. That's a pretty common pattern on like SAT or ACT questions. But the other possibility is that we just need to go over each of these answers and just see if it's possible. So for this one, this is not going to be a problem we can just solve. Like on paper, we have to test out each answer to see if it works. So let's say that there are 10 people in the group, and remember that she wants to pass out all of the tickets and all of the vouchers evenly. So if there are 30 tickets and 10 people, well, 30 divided by 10 is 3. So each person in the group is going to get 3 tickets. But the problem comes up when there are 75 vouchers, because if you tried to divide that among 10 people, well, then you're going to end up with, well, you can't divide this by 10. It's going to be 7.5. And you're not going to give someone half of a voucher. So 10 is not going to be a reasonable answer. What about 15? Well, if we try to divide these evenly among her coworkers, 15 of them, well, 30 divided by 15 is 2. So each of them in the group is going to get 2 tickets. And if we divide 75 for the vouchers by 15, then that's going to be 5. And remember, if you didn't know this, you can put this in a calculator. So in this case, we can actually divide the tickets and the vouchers evenly. So it looks like 15 is going to be the answer. And if we want, we can just double check the other answers. So 25, you wouldn't be able to divide the tickets evenly because 25 of them are going to get 1 ticket. And then you have 5 extra ones, and what are you going to do with those? And then 30 wouldn't work either, because you could divide the tickets evenly, each one would get 1, but then for the vouchers, each person's going to get 2, that's going to make 60, and then you have 15 extra that you have to pass out. So only 15 is going to work here. So it looks like the answer to our question is going to be 15. Okay, I've already seen the first 2 questions before this video, but the rest of them I just went into blind, so let's see how I did. What? Bro, I have to like give you my email to get my answers? Oh, hey, look at that. We got 7 out of 7 correct. And my prize is I will now get junk mail daily for the rest of my life. According to the ACT website, there are 5 different kinds of math that could be on the exam. So here are 5 example problems, one for each of those types of math so that you'll be ready for the exam. So here's the first example that we'll be doing in this video. It says, what is 3/4 to the power of -2? So remember that an exponent is basically just multiplying the same thing over and over. So for example, if we had 2 to the power of 3, that's the same thing as 2 times 2 times 2, which is 8. But for this, that seems kind of weird because, like, how do we multiply something -2 times? That doesn't really make sense. Well, let me show you how to do negative exponents. So basically, we're just going to ignore the negative sign for now, and we're going to treat this as 3/4 to the power of 2. So that means we need to multiply 3/4 by itself twice. So we're going to have 3/4 times 3/4. Now remember that to multiply fractions, we need to multiply the tops and multiply the bottoms. So in this case, 3 times 3 is 9, and 4 times 4 is 16. So that means that 3/4 to the power of 2 is 9/16. Now what does this negative sign do to this? Well, basically a negative exponent flips the fraction around. So because this is a negative exponent, our 9 over 16 is going to turn into 16 over 9. And let's say, for example, you had just a number that wasn't a fraction and you had a negative exponent. Well, remember that a whole number, a number that's not a fraction, is actually over 1. So flipping it would turn it into 1 over that number, or in this case, 1 over 3. So in this case, our final answer is 16 over 9. So now that you know how to do exponents, those kinds of problems will hopefully be pretty quick on the test. But something like this might take a little bit longer. So let's go over how to do this. Here we have a quadratic equation, which is where you have an x squared, an x, and then just a number by itself. And we need to solve for x. So there's a bunch of different ways to solve quadratic equations, and they'll all give you the same answer. But like by far the fastest way to solve a quadratic equation, if you're able to, is factoring. And on a test like the ACT, being able to do a problem faster is always good. So let's see if we can factor this quadratic equation. The way that we do that is we need to find two numbers that add up to the number next to x and multiply to the number that's by itself. And remember that these signs are included as well. So we're adding to positive 2 and we're multiplying to negative 8. So let's go ahead and start listing numbers that multiply to 8. I'm going to ignore the negative sign for now and you'll see why. So first let's try the obvious one, which is just 1 and 8. 1 times 8 is 8. And to know which one we have to put the negative sign on, you just have to recognize that we are adding to a positive number, which means the bigger number is going to have to be the positive one, and the smaller number is going to be negative so that they could add to a positive number. So our negative sign is going to go on the 1, and negative 1 times 8 is negative 8. So we know that these multiply to negative 8, but if we add these together, we get negative 1 plus 8. That's the same thing as 8 minus 1, which is 7. And we are looking for them to add to 2, so that does not work. What about 2 times 4? 2 times 4 is 8, and we have to put the negative sign on the 2, because if we put the negative sign on the 4, then we would add to a negative number because 4 is bigger than 2. So these multiply to negative 8, and if we add these together, then we get 4 minus 2, which is 2. And that is the number that we're looking for, which means that our two numbers are negative 2 and 4. So because we were able to figure out these two numbers, that means we are able to factor, and we are going to use these two numbers in our factoring. So basically the goal of factoring is to turn this equation or quadratic equation into two sets of parentheses. And to know what numbers to put in the parentheses, we use these two numbers here. We got negative 2 and positive 4. So we're just going to put those numbers inside the parentheses. So now how do we use this to solve our quadratic equation, to solve for x? Well, you might recognize that because these do not have a sign next to each other, that means it's multiplication. So we're multiplying these two sets of parentheses together. And whenever you multiply anything by 0, then the whole thing becomes 0. And we know that this equation is equal to 0. So for example, if x minus 2 was equal to 0, it would be 0 times this, which is 0. Or if x plus 4 was 0, the whole thing would be 0. So there are two ways that this equation can be equal to 0. So we're going to split this up into x minus 2 equals 0 and x plus 4 equals 0. We can only do this because the equation is equal to 0. So now we just need to solve for x in each of these individually. So here we have x minus 2 equals 0. We need to get x by itself. So we're going to get rid of this minus 2. And the way that we do that is by doing the opposite of minus, which is plus, and adding 2 to both sides. So these cancel out, and we just have x equals 0 plus 2, which is 2. So 2 is one of our answers. On the other side, we need to get rid of this plus 4. So to do that, we're going to do minus 4 on both sides. So these cancel out, and we just have x equals 0 minus 4, and the 0 is not doing anything, so that's just minus 4. So minus 4 is our other answer. So we found our two answers, x is equal to 2, and x is equal to minus 4. So our third problem in this video is going to have to do with functions, which is another one of those important categories on the ACT. So we have an f of x here, and it says it's the square root of 4x minus 1. But instead of f of x, it wants us to find f of minus 2. So remember that f of x in a function is basically just the same thing as y. So you have a y and you have an x, so you could like plot this on a graph if you wanted to. But to solve a function, in this case, it wants us to find f of negative 2. You'll notice that f of negative 2 is the same thing as f of x, except we've changed x into negative 2. Which means that on this side of the equation, we need to do the same thing. We need to take x and turn it into negative 2, and then that's going to give us some number. So I'm going to rewrite this side of the equation. but instead of x, we're going to put -2. And we're going to put it in parentheses because if we didn't, this would say 4 minus 2. And when you have a number and a letter next to each other, that means multiplication. So we want to keep that as multiplication by putting this in parentheses. This is 4 times -2. So now let's just simplify what we have here. So here in this inside of the square root, we have 4 times -2. 4 times 2 is 8. And we have one minus sign, so the minus sign stays. And then this -1 here is just going to stay right here because we didn't do anything with it. And now let's continue to simplify this. So here we have -8 minus 1. If you're ever confused about negative numbers, just think of it as like money. So you lost $8 and then you lost another dollar, so you are down $9. So the last thing to simplify is to just figure out what the square root of -9 is. The only problem with that is that you can't take the square root of a negative number, because if you multiply two positive numbers together, you'll get another positive number. But if you multiply two negative numbers together, you'll still get a positive number. So you can't take the square root of a negative number. However, we can take the square root of negative numbers by using imaginary numbers. So imaginary numbers are always written with the letter I, and the letter I is equal to the square root of -1. So what I'm going to do is I'm going to split this up into two square roots. I'm going to split this up into the square root of -1, which we will turn into I later, times the square root of +9. Because if you multiply these together, you'll get 9 times -1, which is -9. So the square root of -1 is the letter I, and the square root of 9 is 3, because 3 times 3 is 9. And in algebra, we usually just put the number before the letter, so I'm going to turn this into 3I, and that's it. Our answer in this case is 3I. That is f of -2. So the next category that the ACT lists is geometry, but I'm going to save that one for last, and we're going to do probability. So this one is a probability word problem. It says Gerald rolls a die twice. What is the probability that his first roll is an even number and his second roll is less than 3? So for this probability to happen, there need to be two things that both happen. So the first one is A, that he rolls an even number on his first roll, and then B is that he rolls a number less than 3 on his second roll. So let's figure out the probabilities of both of those things, and then we can figure out the probability of both of them happening. So for this, we're assuming that this is a 6-sided die, so 1 through 6. So it says first he needs to roll an even number. What are the chances of that? Well, how many numbers on the die are even? Well, 2 is an even number, 4 is an even number, and 6 is an even number. But 1, 3, and 5 are odd numbers, so those don't count. So we have 3 different numbers that he can roll out of 6 numbers in total. So out of the 6 numbers on the die, 3 of them will make this true. So his chances are 3 out of 6. And this fraction can actually be simplified. So we have a 3 at the top and a 6 at the bottom. If we divide both the top and the bottom by 3, then that will give us 1 for 3 divided by 3 over 6 divided by 3 is 2. So 3 over 6 is the same as 1/2. So 1/2 is the probability of him rolling an even number. Now let's look at the probability of on his second roll, he rolls a number less than 3. How many numbers on the die are less than 3? Well, 1 is less than 3, and 2 is less than 3, but that's it. There are no other numbers on 1 through 6 that are less than 3. So that means he has 2 numbers that he can roll out of the 6 possibilities. So he has a 2 out of 6 shot at making event B true. And this fraction can be simplified as well. And I can see that because these are both even numbers. So that means I can divide both of them by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So his chances of rolling a number less than 3 is 1 over 3. So we know the chances of him rolling an even number, and we know the chances of him rolling a number less than 3. So how do we figure out the chances of both of them happening? Well, because these are two separate dice rolls, these are not affecting each other in any way. That means all we have to do is multiply the two fractions together. So he has a 1 in 2 chance, and then that's multiplied by a 1 in 3 chance. And remember that to multiply fractions, you multiply the tops and bottoms. So 1 times 1 is 1, and 2 times 3 is 6. So for him to roll an even number on his first roll and then roll less than 3 on his second roll, the total chances of both of those happening are 1 and 6. So here's another example, and this one is going to be geometry. And according to the ACT, this one also includes trigonometry. Now you might be saying, well, I don't know anything about trigonometry. I never took trig. I don't know anything. Well, I'm going to show you the basics of trig in about like 2 minutes. All you need to know about trig is SOHCAHTOA. Basically in trig, everything we do is about 3 different ratios. So we have sine, we have cosine, and we have tangent. And these are abbreviations. They're abbreviated sin, cos, and tan. So each of these are basically just different sides of the triangle. So for example, sine is opposite over hypotenuse. By the way, this is the angle here that we're talking about. This little symbol here means theta. It's basically just a letter that shows you that there's an angle there. So opposite is the side that's opposite of this angle. So here's the angle, and the side opposite it is 3. So 3 is our opposite. Then this side right here is actually called our adjacent side because it's the one that's right next to our angle. The angle's touching it. And then the longest side, the diagonal side, is always the hypotenuse. By the way, the other ones, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA is basically just an acronym that tells you what these are. So this says that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It's SOHCAHTOA. So in this case, it's saying that we need to find sine of theta, and theta is right here, like I said. And remember that sine is opposite over hypotenuse. So which one is the opposite? Well, opposite this angle is 3. So our opposite is going to be 3. That's going to be the top of our fraction. And then the hypotenuse is the diagonal side. It's the longest side. And the longest side is 5. So 5 is going to go at the bottom of the fraction. And that's it. The sine of this angle is 3 over 5. I've been making ACT videos for a while now, and I've been getting a lot of comments saying that the math section is the part that they're most scared about. And honestly, I think the biggest reason for this is because they don't know how to prepare for it. So what if I told you that there was a 5-step system you could use right now to prepare for the ACT? I don't care if you're watching this the night before or a month in advance. You can do these 5 steps right now to prepare for the exam. So let's start with step 1. This is a piece of advice that I think works for getting good at any kind of math, not just the ACT. Do you know that feeling when the teacher is going through a lesson and it's just going super fast and you can't keep up and you're not understanding any of it? Well, a lot of people get discouraged because they think that it's just because they're bad at math that they can't understand it. And I feel like usually that's not the case. I think that the more common reason is because the teacher is assuming that the student knows something from a previous math class, even though they've forgotten it. The truth is that the number one way to get better at math, including the ACT math section, is to make sure that you have the basics down. And on the ACT, these basic concepts are going to be in almost every single problem. So it's really important that you know them. So what are these basics? Well, just as a few examples, you should know how to solve for x in a problem, especially if it's on both sides of the equation. You should also be able to plot a point on a graph. So if I told you to plot 4, -2, would you be able to do it? Also, would you be able to graph the equation of a line, like y equals -3x plus 1? Also, are you able to simplify expressions down to get them as simple as possible? These are some of the most important algebra skills you need to have going into the ACT. And just making sure that you know these first is going to be like 10 times more helpful than just jumping right into ACT problems. Now, once you've gone over the basics, it's time to start getting into the test itself. But a lot of students who are studying for the ACT will just skip this step and go right to step 3. So here's why you should make sure to do this step first. What a lot of students do is they just go right into solving problems and going to find some ACT practice problems. And maybe they'll get a few right, but eventually they'll get ones that are a little too hard and they'll start to feel demotivated. So instead, before you start jumping into problems yourself, you should first watch other people do example problems. So for example, you could go onto YouTube, search up ACT example problems, and just watch some walkthroughs. Of course, my biased recommendation is to watch my videos, but other people have good ones as well. And after you've watched a few problems, just to get a feel for what the test is like, then you can start pausing the video before they work out the problems and try to work through them yourself. The goal in step 2 is not to get every single problem right, it's just to get a feel for what the test is like and to watch other people's strategies as they solve problems. Now, once you've learned the basics and watched some example problems to get a feel for the test, the next step is possibly the most important one. But even if you're already doing it, you might be doing it wrong. So here I am on the ACT website, and what you're going to want to do is go to students and parents, and then you're going to want to go to, wait, where are we going again? Yeah, test prep. That's what we're going. You want to go to test prep. And then here you're going to find some practice problems that you can do. So there are practice quizzes. I think those are just like little 7-question, quick little practice things. And then we also have full-length practice tests. But that doesn't mean that you have to sit there and do a full-length practice test. Our goal here is to just get you used to solving problems on your own. And you should be trying to solve these problems on your own from start to finish. Obviously, you're not going to get every single problem right. You're going to come across some hard ones. So I recommend starting with easier ones first. Usually in the full-length practice tests, the earlier numbered ones are easier than the later ones. Now, here's the most important thing. If you get a problem wrong, like for example, this one right here, you can try to work this out yourself. If you get this one wrong, you should not just move on to the next question. You need to see what the right answer was, find out why you did the problem wrong, and then come up with a takeaway that you can use for the future. Now, once you've practiced doing a few problems, you can even try it in a timed environment, just like the real test. So you don't have to do a full-length test. You can, for example, do one of these 7-question quizzes in 7 minutes. Because on the real test, you're going to have to do about a problem per minute. And as the test day gets closer, if you really want to try hard on your practice, then you can do a full-length math section. Give yourself 50 minutes to do 45 problems. Okay, so you've learned the basics, you've watched other people do problems, and you've done your own. So what else is there to do? Well, no matter what you do for your practice, chances are you're going to come across problems that you don't know how to do. Like, let's face it, right? It's going to happen. Or you'll come across problems that you do remember how to do, but you know they're going to take a long time because you're not really sure what the fastest way is to do it. So before we go into the test, we want to make sure that we're using all of the tools that are available to us to get through questions as fast as possible. Now, I don't know if you've heard about the SAT, which is a similar test, but people always are freaking out about Desmos as the new greatest thing that's going to save people's SAT scores. And the ACT actually allows you to use Desmos as well, if you're doing the digital version. If you're doing the paper version, you can actually use a graphing calculator, which does basically exactly the same thing. So this is an example of what Desmos looks like, and I do have a full video on this if you're interested, but let me just show you pretty quickly what it is. Basically, it just allows you to plug in equations and put them on the graph. So if you needed to graph y equals 2x minus 3, well, there's the graph of y equals 2x minus 3. And you can actually use this to solve a variety of different problems. So I want to make 2 things clear about Desmos / your graphing calculator. Number 1, you need to learn how to use it. You're not just going to pull up on test day never having used this before and then suddenly know everything about it. You should practice doing problems with Desmos or your calculator. And the second thing is that it's not a magic hack. You can't use it to solve every problem. So you probably don't want to try to rely on it for every single problem. That'll just slow you down. The truth is that Desmos is just a tool. It can help you with a lot of problems, but it's not going to save you. And by the way, make sure your graphing calculator is allowed. There are some calculators you're not allowed to bring to the ACT. So make sure you check that out. So you've gone through all 4 of these steps. And now after this, it's the day before the test. Or maybe it's already the day before the test when you're watching this, but still, let's say you've gone through the 4 steps. Here's what you need to do the night before your exam. Number 1 is kind of obvious, but get good sleep. I mean, maybe you stay up till 3 a.m. sometimes, but if you're going to do it on any night, don't do it on the night before the test. The second thing is super important. Make sure you have everything you need for the test. That means you need to have your admission ticket so you can get admitted and not kicked out. You also need your photo ID. You need to make sure you have at least 2 pencils. You never know if you bring 1 pencil, if you're writing and the lead breaks and then you sharpen it and then the lead breaks again. It happens. Make sure you bring your calculator, your approved calculator. Make sure you've checked for that. Make sure you bring some snacks if you want to for your break, for some brain food. And finally, you're allowed to bring a timing device, like a stopwatch or a watch, so you don't have to rely on the person being like, 10 minutes left, 5 minutes left. Instead, you can just always know how much time you have left. So you're allowed to bring that to the test. Just make sure it doesn't make any noise or beeping sounds. And finally, if you want to, maybe do a few practice problems the night before, just as a good refresher and maybe a confidence booster. The ACT is coming up, and in my opinion, the best way to prepare is to practice. So here are 5 practice problems to help you get ready for the ACT math section. So here's the first problem that we'll be doing. It says if 3y equals 4x plus 1, what does x equal? So we're not going to be able to determine exactly what number x is equal to, but we can solve for it in terms of y. So let's just try to get x by itself. Here we have a 4 in its way and a plus 1. And we need to get both of those onto the other side of the equation to get x by itself on its own. So I usually like to get rid of addition and subtraction first, so I'm going to get rid of the plus 1. And we have to do things to both sides of the equation. So I'm going to do the opposite of plus 1, which is minus 1 on both sides. So the plus 1 and minus 1 cancel out. On the right side, we just have 4x. And on the left side, we have 3y minus 1. Now, this has a letter and this doesn't, so we can't subtract these. They're not like terms. So we're just going to leave it as 3y minus 1. And now the only thing in x's way of being by itself is this 4. And whenever you have a number and a letter next to each other, that means multiplication. So I'm going to do the opposite of that, which is division, and divide both sides by 4. So the 4's cancel out. On the left side, or on the right side, we have x, and on the left side, we don't really have anything we can simplify. We have to divide the 4 out to both the 3y and the minus 1. But 3 over 4 can't be simplified, and 1 over 4 can't be simplified. So we're actually just going to leave this as 3y minus 1 over 4. And that's actually all we're able to do here. There's nothing to be simplified because we don't know what y is equal to. So our final answer is that x is equal to 3y minus 1 over 4. Okay, here's our second problem, and this one's kind of a word problem. There are a lot of these on the ACT. It says that a canoe is traveling at 12 miles per hour. What is its speed in feet per second? So to solve this one, to do some conversions, I think I'm going to write this as a fraction because that's what per means. It means like a fraction bar. This canoe is traveling at 12 miles for every 1 hour. Now for this problem, we need to do 2 different things. It wants feet per second. So we need to convert the miles into feet, and we need to convert the hour into seconds. And then we just need to see what we get. So 12 miles is how many feet? Well, you probably don't know that off the top of your head, but the problem gives us a hint. It says that 1 mile is equal to 5,280 feet. So to convert miles to feet, we just need to multiply 12 by 5,280. And when we do that, we're probably just going to get some giant number. Let's go ahead and see what that is. Okay, it looks like we get 63,360. So that's cool and all, but we have to turn the hours into seconds now because it's not feet per hour, it's feet per second. So how many seconds are in an hour? Well, you might not know that off the top of your head, but we know that there are 60 minutes in an hour. So we can turn 1 hour into 60 minutes, and then every minute has 60 seconds. So we can multiply 60 times 60. And that's going to give us 3,600. So the canoe is traveling 63,360 feet in 3,600 seconds. But remember that the question is asking for feet per second, like every 1 second. So how do we simplify this down? Well, remember that fractions are just the same thing as division. So we can just divide 63,360 by 3,600. And that should give us 17.6 feet for every 1 second. If you want to think of this as like simplifying fractions, you can think of it as dividing both the top and the bottom by 3,600. And that forces the bottom of the fraction to just be 1 second, which is what we want. So rewriting our answer to be better, the final answer is that the canoe travels 17.6 feet per second. Okay, here's the third problem. It says that the first 5 terms of an arithmetic sequence are 13, 21, 29, 37, and 45. What is the 20th term? Now, whenever I see a sequence of numbers like this, the first thing I do is try to find the pattern. What is it about these numbers that makes them a sequence? And even if you don't know what an arithmetic sequence is, you can still try to figure it out. And you might notice that it adds 8 every time. 13 plus 8 is 21, plus 8 is 29, plus 8 is 37, plus 8 is 45. And even if you didn't know that, you could just do like 29 minus 21, for example, that would give you 8. and then just see if that works for every number. Now, what you could do for this problem is you could just write out the numbers and then just continue the sequence until you get to the 20th one. Like you could go 53, 61, and so on. But that would take a long time. And remember that on the ACT, your problems, you have to be doing them like a problem per minute. So there is a faster way to do this. If we were to do this manually, what are we doing? Well, we're doing addition repeatedly. We're repeatedly adding 8. And repeated addition is just the same thing as multiplication. So we're on the 5th term right here, and we want to get to the 20th term. Well, that's 15 more numbers that we have to write. And each time we're adding 8. So we have to add 8 15 times. Well, that's just the same thing as 8 times 15. That's the definition of multiplication. 8 times 15 is adding 8 15 times. So what is 8 times 15? Well, if you put that in your calculator, you'll get 120. So if we add 120 to 45, then we should get our 20th number. And if you put that in your calculator, you'll get 165. So just like that, we've determined that 165 is the 20th term. And in case you were curious, here is the entire sequence, and 165 is indeed the 20th term. So 165 is our final answer. That is the 20th term of the sequence. Okay, here's another word problem for us. It says that Jeff earned $20,000 in his first year at a job, and then each year he gets an equal raise. And eventually, in his 4th year, he earned $23,900. So whenever I see a question with a bunch of information, actually the first thing that I do is I look down at the last sentence. I know that seems like cheating, but it's just going to throw a bunch of words and stuff at us, and then it's going to ask us a question. The question is, in total, how much did Jeff earn in all 4 years? So that's what I'm looking at first. Now that I have in my head that we need to find the full 4-year amount, then I go back to the information and try to pull out what's important. So what's the total for all 4 years? Well, it's the total of the first year, second year, third year, and 4th year. And the problem gives us information for 2 of those years. It says that in the first year, Jeff made $20,000. So that's easy. We've already figured out the first year. And it says in his 4th year, he made $23,900. So, I mean, we already have 2 of the years, but we need to know what he made in the second and third years to add them together. Now, to solve this, we're going to have to do a little bit of big brain thinking, right? Because the one other piece of information it gives us is that he gets an equal raise each year. So from the first to the second year, he got some sort of raise. Second to third year, he got the same raise. And then from the third to the 4th year, he got the same raise again. So in total, he got 1, 2, 3 raises. So we can figure out from there based on how much money his salary increased by, we can figure out how much each raise was. So I don't know if you really need your calculator for this, but just because why not? 23,900 minus 20,000 is 3,900. So in total, the total raises was 3,900. But that raise came about over 3 different years, 3 different raises. So how do we figure out the amount for each raise? Well, we can just divide that by 3. And if we do that, we should get $1,300. So it looks like every year he got a $1,300 raise. So let's go ahead and see what the second and third year totals would be in that case. Well, after the first year, if he got a $1,300 raise, he would now have $21,300. And on the third year, if he gets another $1,300 raise, he would now be paid $22,600. And just to make sure it's a sanity check, we can check from the third to the 4th year. And indeed, if we add $1,300 again, we get $23,900. So this is how much he would have had to be paid getting an equal raise each year. So now remember that the question is asking what was he paid in total over the 4 years. So let's just go ahead and add these together. And when we do that, we get a total of $87,800. So that right there is our final answer. And if you just want to do another sanity check, it makes sense. You got about $20,000 each year, so about 80,000 makes sense. Okay, for this problem, we're going to need to use a little bit of geometry knowledge because it talks about a quadrilateral, which is just a fancy word for a 4-sided shape. Now, as always, we look down at the bottom of the question and it says, what is the value of x? So that's what we're looking for. So now that we know that, let's go ahead and look at the rest of the question and see what we can pull out. So it says that in this quadrilateral, 4-sided shape, two opposite angles each measure 2x minus 1 degrees. So obviously we don't know how many degrees that is actually. We just know that there's an x in there. And then it says the other two angles each measure x plus 4, which is still not very helpful. So we have to somehow find the value of x. Now in these situations, I kind of like to diagram it out, but you don't necessarily have to do this for this problem, but just in case you want to, I'm just going to draw a random quadrilateral. Like, ooh, four-sided shape. Look at that. So it says that two opposite angles measure 2x minus 1. So that's going to be this one and this one. So you see how they're opposites? This is what opposite means. They're just like opposite of each other on the diagram. And then the other two angles are going to measure x plus 4. Now, personally, I don't think this is that helpful, but just in case you wanted to visualize it, well, this is what we need to do. We somehow need to turn this into an algebra equation because whenever it wants you to solve for x in a geometry problem, it usually means you can turn it into an algebra equation. I know that every single four-sided shape has 360 degrees total. And the rule is that it always has 180 degrees for every side minus 2. So like, for example, a triangle has 180 degrees total. Then a four-sided shape has 360 degrees total. Then a five-sided shape would have another 180, that's 540, and then so on. So this is an important rule to know that quadrilaterals, four-sided shapes always have 360 degrees. So if we were to add all four of these angles up, it would give us 360. So why don't we actually just write that as an algebra problem? So we can just add all four of these angles up, and we can just do x plus 4 plus x plus 4 plus 2x minus 1 plus 2x minus 1. And I'm running out of room here, but this is all going to equal 360. So now let's just go ahead and solve for x. So first of all, because these are all addition, these parentheses are actually kind of useless. So let's just add together all of the x's. So we have an x, then we have another x, that's 2x, plus another 2x, that's 4x, plus one more 2x, that's 6x. So 1 plus 1 plus 2 plus 2. So in total, that gives us 6x. And then finally, let's add up the numbers. So we have 4 plus 4 is 8, minus 1 is 7, minus 1 is 6. So 4 plus 4 is 8, minus 1 is 7, minus 1 is 6. So that's going to put a plus 6 at the end of this. So just like that, we've simplified all of these angles down into just 6x plus 6. And we know that this has to equal 360. So now we just need to solve for x. And remember that I like to get plus and minus out first. So to get rid of the plus 6, let's do the opposite of plus, which is minus, and subtract 6 from both sides. So these cancel out. On the left side, we just have 6x. And on the right, we have 360 minus 6. If you want, you can put that in your calculator. You'll get 354. And now finally, this is multiplication. So I'm going to do the opposite of multiplication, which is division, and divide both sides by 6. So these cancel out. And I'm running out of room here, but on the left, we just have x. And on the right, we have 354 divided by 6. And if you put that in your calculator, you should get 59. So just to double check the problem to make sure it didn't say find this angle, it does say we just need to solve for x, which means that our final answer is x is equal to 59. If you're taking the ACT soon, then you're probably wondering, how hard is the math section? Well, it's hard to say. Okay, that was not funny at all. The ACT math problems range from pretty easy to the hardest test you've ever taken in your life. So in this video, I'm going to go over all 5 levels of difficulty that you can expect to see on the ACT math section. So why don't we start with level 1? Because, like, it comes first. So for this problem, we have a function f, and it's defined by the equation f of x equals x squared minus 3. Now, this question isn't just asking us to find f of 2, it's asking us to find f of 2 plus 4. But just don't be scared about that because that literally just means we find f of 2 and then we just add 4 to it. So here's our function, and you'll see that when we have f of 2, we are replacing x with 2. So in the right side of our function, we're going to have to do the same thing. So to find f of 2, I'm just going to take this x and replace it with 2. And now we just need to simplify this down. So 2 squared, that's 2 times 2, which is 4. And 4 minus 3 is equal to 1. So f of 2 is equal to 1. but the question is asking for f of 2 plus 4. So let's just add 4 to it. 1 plus 4 is equal to 5, which means that 5 is our answer, and that's the letter A. So for this problem, we have some geometry stuff. It says that the lengths of corresponding sides of two similar right triangles are in the ratio 3 to 4. The hypotenuse of the smaller triangle is 18 centimeters long. How long is the hypotenuse of the larger triangle? So this is an example of one of those problems where they try to bombard you with as many math vocab terms as possible to make you wonder what it is you're even doing. But if we just try to focus down on what it's actually trying to say to us, then it's not as hard as it looks. The key word here is that these are similar right triangles. So similar triangles are basically the same shape of triangle, but they're just different sizes. Like one is a bigger version of the other. And it says that the sides are in the ratio 3 to 4. So whenever you see a ratio, then that means, for example, if a side of one of the triangles was 3 inches long, then the other one would be 4 inches long. Now, it does say that it's the hypotenuse of the smaller triangle, but that really doesn't matter because the hypotenuse is just the longest side, so who cares? But it does say that of the smaller triangle, it's 18 centimeters long. And we just need to find how long that side is for the larger triangle. So to solve this, we can just go ahead and use our ratio of 3 to 4. But we know that the 18 centimeters is the smaller one. So that's going to be the 3 of our ratio. So what is the length of the larger side if that's the 4 of our ratio? Well, the way I like to think about ratios is I think about how much it's being multiplied by. So to get from 3 to 18, we have to multiply by 6. And the way you can know that is just 18 divided by 3. That's 6. So if we're multiplying the small number of our ratio by 6, then if we multiply the large number of our ratio by 6, then what do we get? Well, 4 times 6 is 24, which means that the hypotenuse of our large triangle is 24 centimeters, or option C. And by the way, even if you had no clue how to do this, you still could have made this a 50-50 because it says the smaller one is 18. So the bigger one is not going to be 15 or 18. It's going to be like bigger than 18. For this problem, we need to find the y value of the solution to this system of equations. So normally the answer to a system of equations has both x and y, but they're nice enough to only make us find the y value. Now there's two main ways to solve a system of equations. There's substitution and there's elimination. Now elimination looks like it would be really annoying to try to do right now, but substitution is actually fairly simple, because we have x by itself already. Basically, because we're solving for y, we want one of these equations to just have y in it and not x, so that we can solve for y. But it says here that x is the same as 3y minus 4. So why don't we just replace x in our second equation with 3y minus 4, because it's the same thing. And if we do that, then we're going to completely get rid of x in this equation and we only have y. So I'm going to rewrite this second equation, but instead of x, I'm going to write 3y minus 4 because it's the same thing as x. And you'll see now that all we have in this equation is the letter y. We don't have the letter x. So now we just need to get y by itself. The first thing that I'm noticing we can do here is the distributive property, because we have a number in front of parentheses. So we need to multiply the 5 out to the 3y and to the minus 4. So 5 times 3 is 15, and then the y stays. And then 5 times negative 4, well, 5 times 4 is 20. And we have one minus sign, so the minus sign stays. And then the rest of the equation is going to stay the same as it was before. Now, what else can we do to simplify? Well, we are trying to get y by itself, but we have two y's here. Now, because we have two y's, we can actually combine them. We can combine like terms. So don't forget about the minus sign. This is 15 minus 9. 15 minus 9 is 6. And then the y stays because we're combining like terms. And now we haven't touched this minus 20, so we're going to keep the minus 20. And we also haven't touched the minus 12, so that'll stay minus 12. So now we just need to get rid of this 6 and this minus 20 to get y by itself. I usually like to get rid of addition and subtraction first so that we don't have to deal with fractions. So I'm going to do the opposite of minus, which is plus, and add 20 to both sides. So these cancel out. On the left side, we just have 6y, and on the right side, we have negative 12 plus 20. That's the same thing as 20 minus 12, which is 8. And now we just have a one-step problem. Whenever you see a number and a letter next to each other, that means multiplication. So I'm going to do the opposite of multiplication, which is division. So the 6's cancel out. On the left side, we just have y. I'm running out of room here. And on the right side, we have 8 over 6. So that's actually a fraction that we can simplify. I can tell that because these are both even numbers, which means they can both be divided by 2. So 8 divided by 2 is 4, and 6 divided by 2 is 3. And 4 over 3 can't be simplified anymore, which means that our answer is y equals 4 over 3, or D. So for this one, we have two equations. We have 6x plus 3y equals 3, and 8x plus 2y equals 6. And we have the slope of the first one is m1, and the slope of the second one is m2. So based on that, we have to decide which of these equations is true. But I don't really see how we can find that out unless we know what the slopes of both of them are. So remember that to find the slope of an equation, we usually use slope-intercept form, which is y equals mx plus b. And in this form, m stands for the slope, and b stands for the y-intercept. But if we take a look at this first equation, you'll notice that it's not in slope-intercept form. So to be able to pull the slope from this equation, we need to put it in slope-intercept form. The key to slope-intercept form is that y is by itself. So in this equation here, we're going to try to get y by itself. First of all, this 6x is in the way, so I'm going to subtract it from both sides of the equation. So these cancel out. On the left side, we just have 3y, and on the right side, we have 3 minus 6x. One of them has a letter and one of them doesn't, so we can't actually combine those. It's just going to stay as 3 minus 6x. And now finally, we just need to get rid of this 3 being multiplied to y. So I'm going to do the opposite of multiplication, which is division. So the 3's cancel out. On the left side, we just have y, and on the right side, we have to divide the 3 from both parts. So 3 divided by 3 is 1, minus 6 divided by 3, which is 2. And then the x is just going to stay. And now our equation is in the slope-intercept form. I know it's a little weird because the b is before the m, but it doesn't matter. The slope is the number that's multiplied to x. In this case, that number is negative 2. Remember that the minus signs always stay with your slope. So we've determined that m1 is equal to negative 2. So let's go ahead and find out what m2 is now. Here's our second equation, and we're going to do it the same way. We're going to try to get y by itself. So I'm going to start by subtracting 8x from both sides. So these cancel out. On the left side, we just have 2y. Then on the right side, we have 6 minus 8x. Now this 2 is being multiplied to y, so I'm going to do the opposite of multiplication, which is division, and divide 2 on both sides. On the left side, we're just going to have y, and on the right side, we're going to divide the 2 out to both numbers. So 6 divided by 2 is 3, and 8 divided by 2 is 4, and the x is going to stay. So again, this is backwards, but it's still in slope-intercept form. The slope is the number in front of x, or m, and the number in front of x here is negative 4. So negative 4 is our slope. So there you go. We've determined that the first slope is negative 2, and the second slope is negative 4. But what do we do with that? Which of these equations is true? Well, let's just test out each equation and see if these numbers make it true. So A here is m1 is equal to m2. Well, negative 2 and negative 4 are not equal to each other. They're not the same number. So A is out. B says that 2 times m1 is equal to m2. Well, let's try that out. 2 times m1, which is negative 2, is equal to m2, which is negative 4. Well, 2 times 2 is 4, and 1 minus sign, so the minus sign stays. And you'll see that it actually is true. We get negative 4 on both sides, which means that the answer to this problem is B. For this problem, we need to find the inverse function of this function right here, the cube root of 4x minus 1. Well, an inverse function is basically just the same function, but where x and y are swapped. So to just make this easier on ourselves, I like to replace f of x with the letter y. Now to find the inverse function, we just need to swap x and y around. So instead of y, I'm going to put the letter x, and instead of x, I'm going to put the letter y. Now I guess this is the inverse function, but remember that a function usually has y by itself, or f of x. So we basically just need to rearrange this equation around so that y is by itself, and then that will hopefully be one of our answer choices here. I just now noticed that this line here isn't connected and it's driving me crazy, so let's just, okay, there we go, perfect. So let's try to get y by itself. The most obvious glaring thing that's making that annoying is this cube root that's covering everything. So the opposite of a cube root is cubing, putting something to the power of 3, not solving a Rubik's Cube, unfortunately. So remember, we can do whatever we want to both sides of the equation. So I'm going to cube both sides. So the left side is just going to be x cubed, and the right side is going to be everything except for this cube root, because the cube root and the power of 3 cancel out. So it's just going to be 4y minus 1. Now let's continue to get y by itself. I usually get rid of addition and subtraction first. So I'm going to add 1 to both sides. These are not like terms, so this is just going to stay as x cubed plus 1. And on the right side, these are going to cancel out, and we just have 4y. Now, because we're running out of room, I'm going to go ahead and take this and move it up here. And now we just need to get rid of this 4, and it's being multiplied, so I'm going to divide 4 on both sides. These 4's cancel out, so on the right side, we just have y. But on the left side, there's nothing that we can divide out here. We can't divide x cubed by 4, and we can't divide 1 by 4. So it's actually just going to stay like this. And if we go ahead and take a look at our answer choices, we'll see that x cubed plus 1 divided by 4 is answer choice C, which means that the answer to our problem is C. That is the inverse function. So if you've made it through this entire video, then congratulations, you've just done 2 hours of ACT math review. Now at this point, I'm sure you're ready to take on the ACT math section, but if you want, there's one more important thing we weren't able to go over in this video. If you're taking the digital ACT, you're going to have access to something called Desmos. And while I don't think it's going to save you on the test, I think it's going to be pretty helpful if you learn how to use it. And if you're taking the paper ACT, you'll be allowed to use a graphing calculator, which does basically the same thing. So if you want to learn how to use Desmos and how I would use it on the ACT, then this is the video you'll want to watch next. If you have any questions about literally anything in this video, go ahead and leave a comment and I'll be sure to answer it. Thanks for watching and good luck on the ACT. You got this.